Bismillahirrahmanirrahim. Good evening. Today, let's try to do a simple review about how we can upload some curves. It's necessary because it will be helpful to us at next lectures to know how we can calculate the resistance, how we can deal with bundle, how we can calculate the gravity, how we can deal with some electronic device to prove, to discuss some characteristics of them. Let me go directly to this lecture. According to the column below, determine the slope between them, x and y, or let me say between time and velocity. According to these numbers below, when I take a look to these numbers, we can say by increasing one of them, the second will increase too. That's mean theoretically I have a linear relation between them. It's direct linear relation specifically. Let's prove that. Go to x and y, like I said before. I have here some numbers. At first, I must know how much or each 1 second equal how much centimeters. It's necessary to all of the x and y. At first, here I said every 10 seconds equal 1 centimeter. By that, to 50 seconds, I need just 5 centimeters. The same thing to velocity at y-axis. I said every 1 centimeter equal 5 kilometer divided on hour. By that, 15 equal 3 centimeters. And go on. To know the slope, it's a triangle. Slope, it's a one part of the triangle. The degree of this triangle is 90 degree. Slope is equal delta y divided on delta x. That means I must select 2 points from y, and according to these 2 points, another 2 points of x, to can calculate the slope. The slope, that's mean this part of this triangle. Like we know, delta x, that's mean this part of this triangle. Delta y, that's mean this part of this triangle. By that, same thing with the Pythagoras rule, but it's different a little bit. Here, this slope will be very important to us at next experimentals, at next lectures, when we will work to calculate the resistance, the velocity, the gravity, discuss some characteristics of some electronic device. Here, some important notes: slope is unitless, without units, and it's no way to be negatively result, okay? No way, let me say that again. No way to be negatively result. You can take a regular point to determine the slope. It's another important note. Here, it's not a condition to be all of these 5 points according to this line, or this line will not, it's not a condition to through from all of these 5 points. Maybe we'll through from just 4 points, and one of them or two of them will be out of this line. That's mean I have a regular point, like 0, 0, the original point. It's not a condition to throw from this line. The most important thing is must have more than 5 my points must through from my line, not all, okay? Like I said before, at x-axis each 10 seconds, here it's important to write to make your teacher know how you could to determine to how you could work on x and y axis, okay? Slope, the result here is equal 1. When try to take another 2 points from up or down, the result will be the same. It's a one characteristic of slope. Here, conclusion is important by using simple and few words to make me know you have an idea, you have a vision on this curve, you know what you are doing. The relation between v velocity at y-axis and t at x-axis is a direct relation linearly. By that, when it increase someone, the other will increase too. By that, when v increasing, the time will increase and vice versa. Here, you have a homework question. It's important. It will help you to can plot perfectly the resistance curve at next experiment, at next lecture, at next week. Here, another one. When take a look to the column, it's clear. When increased one of them, the other is decreased. That's mean I have linearly relation, but here it's reverse relation, not like the previous one. Here at x and y, each 10 seconds equal 1 centime. By that, 50 equal 5 centime. Each 1 centime equal 5 kilometer divided on hour. Let me put all of these or plot all of these points 1, 2, 3, 4, 5 from up to down, because the first point was from the column 10 with 55. Like I said in the lecture today, slope is a two-dimension figure. Okay, that's mean has some position at x and at the same has another number at y. It's important. Here I have a regular point, no way to make it in the slope. Here I selected the first and last point to plot my slope. The first one and the last, it's up to you because the result will be the same. The number of irregular points must be less than half the number of points awarded. Slope equal here, it's 1. Let's talk about the calculation, the conclusion, sorry, the relation between t, the time, and the velocity or acceleration here. I used acceleration, not velocity. At y-axis is inverse relation. Linearly relation, that's right, but it's inverse, not direct. That's mean when increase one, the other will decrease. That's it. It's a piece of cake, just a review. Here, it's a homework. These homeworks will help you to increase your experience by how we can plot curves, how we can deal with the column numbers, how we can divide it the right distance at x and y. Another one now, the linearly relation is done. Let's talk about the curves or the exponentially relation. It's a curves, not line anymore. Let me solve one of them. It's two kinds. The first one is according to the column below between time and customer number patients at y-axis, show the relation between them. T time weeks, patient number. Here, it's important from few numbers to huge numbers, because that you must be careful when divided the axis with right distance. Here, each 10 weeks equal 1 centime, or you can write each 2 centime equal 10 weeks. That's at the situation. Maybe you will need uh, 10 centimes instead of 5, but I selected to be each 1 centime equal 10 weeks. Now, x-axis is done. Let's talk about y-axis is the most important one, because here at the column I have simple numbers, 50, 40, whatever, and more than 1,000. Here I said every 1 centime equal 200 patients. 200 patients every 1 centime. That means 10 centimes equal 1,000 patients. By that, 13 centime equal 1,300 patients. By that, by make these plot these points with its two dimensions from x and y, I will have a curve, simple curve like that. That's mean at first the patient's number were very small. When increasing the time more to be 20, increased a little bit, but when increased the time to be 50 weeks, the patient number is increased, is explosion, exponentially increased from 10, I'm sorry, from 100 to 2,300. Let's talk about the conclusion. The relation between time and patient is exponentially relation, not linearly anymore. And when increase the time to be more than 40, the result is exponentially increased from 100 to be 1,300. According to this column here, it's a homework. You should to try to solve it to have the necessary experience to can deal with the next questions at the next lectures. According to the column below, between this time and patient number, according to this column here, if we take a look, 0, 20, 40, simple numbers, small numbers, at last 1,500. You should to solve it. It's necessary. At last, according to the column below, at previous example, I had exponentially increasing from simple number to huge number. Here, I will have a reverse situation. A huge number will decrease exponential, decrease, not increase to be simple number, small number. Here it's clear from this column from 100, from 1,300 to B20. Here, every 1 centime was equal 100 patients. By that, 13 centimes equal 1,300. And every 1 centime was equal 5 weeks. By that, these numbers is put it here by use its positions, the two-dimension positions from x and y, to be this relation is clear. I have here exponentially decreasing from 1,300 to 15 weeks, at first 15 weeks, to reach just 20 after 55 weeks. Let's go to conclusion. That's mean here the relation between time and patient is exponential relation, decreasing exponential relation. I forget it to write it here. Decreasing exponential relation, not linearly after or at week number 35. The result is decreased too much, exponentially decreased from 1,300 to be 100. That means every curve has meaning. When you plot a curve, you must know its meaning. That's it. Here it's the last homework. By that you have four solved example plus four unsolved example as a homework. You will write all of these solved and unsolved examples in your notebook, and you will show me at next week. Sorry. Have a good day. Thank you both for watching or listening. Have a good day and see you soon.